So welcome to the lecture number 20 of the deep learning course. And in this session, we are going to continue our discussion on the CNNs, and we are going to see that how we can use this kind of network architecture for the learning, and some of the things that we see with respect to the CNN, how they are actually relevant in our neural network structure. So before starting this session, I just wanted to remind you a equation that we have seen in the last class, because we are going to use this once again. So the idea was this, that if you have, let's assume that you have an plane of say h cross w, and if you apply a filter of size f cross f, so what you are going to get. So, and there was something called stride, and stride says that you are going to put the filter here, and the next filter you are going to put whether into the adjacent place, or how many cells you are going to skip. So let's assume that S is what, that this is going to be your stride. So and there is something also called the padding. So if you are going to apply a padding of P, so what was the formula, means what is the size of the next image that you are going to get. We have seen that if you apply a padding, any kind of padding is going to actually contribute to the h only. So it becomes h becomes what, h becomes h plus 2p. So the formula was this, that you subtract f from this and divide by s and add 1 out of that. This is the new h, sorry, plus 1. This is the new h. And similarly, if you want to find out what is the w, so it is w plus 2p minus f divided by s plus 1. So any confusion on this, any explanation if you want to get on this particular part, please let me know. And but however, this is not needed, because as I told you that we have discussed this into the full detail into the last session, so you can just refer that particular part only. I just wanted to remind you that this is the formula that we are going to use in this particular session. Make sense? All right, so let us start. So this is a kind of means I'm going to bring a kind of problem in front of you that actually we want to solve using a deep learning architecture. So let's assume the problem is this, that you have an image. Okay, let's assume that you have an image, and multiple images are there, and some images there is a car, some image there is a bus, there is a some monument, and there is a flower. Let's assume that these are four category of the thing that are there into your database. So you have images, and all the images can be of one kind. Either it contain car, or it contain bus, or it contains some monument, or contains some flower. So my learning problem would be that if I supply this particular thing, so what I would supply. So from my database, what I would supply to the system, I would supply the raw pixels to the system. So I'm going to provide the, with respect to that image, I'm going to provide the raw pixel to the system, and system should have a classification part. Means it must have a classification head, and at the end it should tell that whether this particular item is car, bus, monument, or flower. Make sense? So what should be into the output layer? Let's assume that this is what the output layer. So how many output would be there? Can you tell me that how many output would be there? 1, 2, 3, 4, 5. How many output would be there? Can you tell me? Can anybody please type? So how many output would be there? How many neurons would be in my output layer? Can you tell me in this particular problem? 4? Definitely 4, because one for car, one for bus, one for monument, and one for flower. So how I develop this kind of system? Most of the time, the classification head that we apply at the final layer is going to be what? It's going to be fully connected system. So some neuron, maybe I can say that 10 neuron I'm going to put it here. Then I can say that 50 neurons I'm going to put over here. So they need to be fully connected. So all these neurons are fully connected. Every neuron is fully connected over here. So a lot of fully connected network architecture is going to be there. So this kind of fully connected network architecture structure would be there. This is my classification head. So my idea is this. So what I'm proposing is this, that you take the image, you feed the raw pixel in your this classification head, and try to get that what is the classification. So how can you find out the right parameter for these kind of things? So here what is happening here, what is happening over here? So here again, let me tell you that it is called the flattening. What does it mean? It means that every pixel one by one, you are going to consider this pixel, then this pixel, then this pixel, then this pixel, and this pixel. So you are going to consider them, put one by one. All these pixels are here. So last pixel is also here, and then you pick this particular pixel and keep putting here and here and here, and similarly all these pixels are keep placed over here. And by this you actually generate what? That you generate a feature vector, and this feature vector is being fed to this particular fully connected one. Make sense? So this is called the flattening you are going to do into this particular way. So do you understand this thing? Any questions on that? So if you want to feed anything, you have to do this kind of this kind of arrangement. Any questions on that? I have a question that is this a good architecture? Uh, Looks like no, this is not a good architecture. Why it is not a good architecture? Because you know that raw pixels don't represent the images very well. So if you have an image and you are going to feed this into the system, so looks like that you are not actually taking care that taking care of the features. So you are feeding the raw pixel, because you know that most of the time. Uh, let me give you an example. So what I wanted to tell you that let me give an example. Let's assume that you have an image, and into the computer vision class, I have also shown you this when I was discussing about the computer vision. That on this same image, if I do this, that if I create another image, that is this image of this value plus 50. If I add 50 to all these things, okay. So whether my first question, whether the image would be same? No, image would not be same because you have added 50 to everywhere. So there would be more brightness. Image is not same. But in terms of monument, car, bus, and flower, whether the image is same? Answer is yes, because it would again, even that image you would say that there is a Taj Mahal. Okay, you would not think that something different has came out, okay, from that. So raw pixel, and why those two things were having the difference? Because you are considering the raw pixel, because based on the raw pixel the things are different. And I just want to give you an example that if you can manage this experiment in anyhow by yourself, try to see this, that if you have a scanner, on this scanner you put any figure, for example your own image, you put that image and close the this particular scanner, because you know that in the scanner you put the image and you have to close it. You close it, and from the computer you just send the command to scan it. By scanning you get the image I1, and I say this that you again give the same command and get the another image. So both the images would be same, yes or no? 100% same. Yeah, because you have not changed anything. You have just clicked on the button. No, nothing was changed. But let me tell you that if you see that pixel by pixel difference, if you find out pixel by pixel difference between these two images, it is going to be a huge number, maybe 500, going to be a very big number. And I can give you another image that is maybe may not be the same image, but the difference between that image could be 30. So all these things are possible. So what I essentially means, and why I can give you this particular image, because given an image I can always add to some to all the pixels, and as I am doing here, I can add some value so that after adding this, the difference between that particular image I can clearly reduce. So it may be possible that I can control this number, and I can make the difference less than this 500 into the different image that I have. So essentially, what I wanted to say is this: that raw pixel don't represent the particular image. So it would be nice that if you can do some kind of feature extraction on this, and you feed features to this particular place, na. So what I wanted to tell, that this particular part, copy. Let me copy and let me paste here. I say that if it into the another arrangement, if you want to put the same thing, how should I do that? Let me do it into this way. Okay. Let me remove this part, and you are with me, and you understand that this particular part is actually this particular part, what I'm going to feed it to over here. So I can remove this. I can say, let me also remove this particular part. Okay. So I say that that I'm going to use this part over here. Is it clear? So instead of using the raw pixel at this particular place, what if I use the features? Okay, this is going to be the better represented, because features are going to be going to represent the same thing in more better way. So this is going to be a good thing to do. Okay, so my question, I have a question for you, that if I say that the first strategy was the strategy A and the second one is the strategy B. This is the strategy A and this is the second B. This strategy is B. Which strategy is better, A or B? B, because you can see that even if now if I add some 50 to this particular thing, edges are going to be the same. Okay, so I'm going to represent the same thing. So this B seems to be a better strategy as compared to the A. All right. Okay, so few. I think in the last lecture itself, and while we were discussing about the computer vision, we actually talked about that this particular the filter that we apply on the image, actually they represent something. For example, if I put 1 1 1 minus 1 minus 1 minus 1, it is going to give you the horizontal error. Horizontal is similarly 1 1 1 minus 1 minus 1 minus 1 0 0 0. It is going to give you vertical edges. So getting horizontal edges, and am I right? I think I'm wrong now. This is going to give you the vertical image and this is going to give you the horizontal image. Okay, so this is going to give you the horizontal one, this is vertical one. Okay, vertical image. So okay, in the same line of thought, if you agree with me, if I ask you that what would happen that if I say this 3 2 1 5 minus 1 2 3 1 5, if I give you this, what is going to happen? I don't know, but maybe some other kind of feature extraction is going to happen with that. Okay, so as detection that we have few minutes back, I told you that actually it is a handcrafted method that I by myself understand that instead of feeding this thing, if I feed edge of the image, it is going to be better representation. So but you know that we sometimes we are not good into finding out the features, na? This is a big problem for us because we don't know that what is the right kind of feature. That's why research is going on. Many of the time people are searching for the best feature for your data. So people keep doing this. So sometime, for example, when you are right now you are telling that edge detector, and instead of edge detector you can say that I can apply another feature such as shift and hog. So this is another feature that I'm going to apply. Somebody can tell that maybe you use both of them, so why you are using the same thing, you can both of them, then you somehow concatenate and do all these things. So multiple things are possible, so people are actually suggesting all these things that you are going to use the extracting the feature and taking this thing. But what I wanted to tell, that this feature can be represented using what? A CNN. And we are not good into the CNN, so why not we can by yourself ask from the system to give me the what is the right feature for you. Because when we build a system, we ask from the system give me the right parameter, so that my classification error is going to be minimized. If my classification error you can minimize using the right kind of parameter over here, so looks like that you are actually good to find out, you are actually able to find out the right kind of parameters for me. However, in this kind of settings, one thing I also want to tell you here, that if you see this particular, you can what I wanted to tell, that if you can see this into a different perspective, and the perspective is this, that in this complete pipeline, there are two parts. One part is this, where you are actually finding out the features. So let me represent it by a box that you are going to find out the features, and after that there is a classification head. There is a classification head, and you feed the image to this particular system and get your probability score, that what is this what this particular item is. In this kind of setting, when I make this kind of arrangement, where is the learning happening? Where is the machine learning part is happening? Do you know what is machine learning? You actually do a gradient descent, change the parameter so that your error is going to reduce and you become better on the system. So what is the place where you are actually changing the parameter? Are you changing the parameter here? Yes or no? Are you changing the parameter here? Are you changing the parameter here? The answer is no, because if you are into this particular scenario where you are by yourself fixing that I'm going to use the S detector, so actually no, you are not going to change anything here because you have fixed it. You are changing the parameter here only. This is the only place where you can change the parameter. Okay, so in this, here also the learning was happening at this point, here also the learning was happening in this point. But if you say that, okay, I don't want to define by myself that what is going to be the feature, I allow the system to use these kind of CNN blocks. If I put the CNN blocks over here, so ultimately what happens, but you can see that this particular block, output of this thing is going to be this vector, and output input needed into the classification is going to be this. So they are directly connected now. What is the meaning of any kind of representation? So whether this representation mean anything? No. Now this particular thing is not going to mean anything, because whatever you feed the input, and after that whatever being generated intermediately, they are directly connected to the next layer. So from the outer perspective, you can see that it is a completely one network. It is a full one single network. The complete thing you can say that as a single network. So this is the another arrangement where I'm telling that if you put the CNN as a parameter over here, so by this you are bringing the learning, which actually you are doing by yourself, human, to this particular part, and the complete thing is now trainable, and therefore the learning is happening here also and here also. In all the parts, the learning is actually now happening. Make sense? Okay. So what I'm telling that to find out the feature, I'm going to apply the CNNs over here. So this is the importance of the CNN. When you put the CNN into the system, what you are saving, that handcrafted method, I would not find out the feature. And this is the big problem. People were not knowing that what is the right feature for this kind of problem for me. So this thing is being automated, and it is a big progress into the computer science and the computer vision domain. Understand? All right. So if you understand this particular part, so what I wanted to tell, that on the image you find out the feature using the different kind of kernels, different kind of CNN kernels. Who is stopping you to use only one kind of feature? Why don't you use one more feature? Why don't you use one more feature? So multiple features can be extracted. Okay. And again, who is stopping you to create the hierarchy of the feature? Means using these things, can you build a better feature out of that? It would be a nice idea to just to apply more things so that you can be more better on the system. So the idea is this, that on the original image you have applied different kind of CNNs, means you are exploring the different kind of possibilities from this particular image, that what is the what is the horizontal image, what is the vertical image, what is the gradient, what is the other thing. So many things you are going to find out into this particular thing, and then you are combining those things to get the higher level construct. Then again you are combining them to get the higher level construct, and after that you are going to apply the classification rate. So this is again a good thing, that CNN one hand it is going to enable you to automatic discovery of the feature, and another way it also enables you to create a hierarchy of the feature. Okay. All right. Any questions till now? Okay. Now I have a question for you, but to ask this question, I want to explain you something. Okay. Let us consider a problem, and the problem is this. Let's assume that you have an image of 4x4 image. 4x4 image, 4x4 image. So how many values you have? 16 value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 values you have. Okay. Make sense? Cut. 16 values you have. There is a question, sir, why are we using multiple layers, filters, kernels, since kernel are minor functions? Cannot many filters kernel be considered into one linear? So Mohit, you can speak. What is the problem? Let me know that what is your problem.
So you said that we could use many layers that represented different features, right? But since
Should I
these
go to the
filters
previous
are,
slide? So here
yes,
when
sir.
I was telling this thing, this is the point.
Yes, sir. So the
Here,
below point.
tell me.
Yes, sir. But since kernels are like mainly linear functions, right? So if you it, like I was imagining, isn't it a case like we had done in neural networks where since all of them are linear, like any combination can be represented by a single kernel?
Mm,
Like won't
look,
like even if you have two three layers, you in the end you
let me
can
tell you.
also get same
Let
result.
me tell you that actually what is happening now. You are confusing by considering at one part and considering the complete image. These are the two different things. Okay, CNNs are actually applied on one part of the image. They don't see the complete image because CNN is a small filter that is applied on this particular part only. First thing. And what happens that if we and this thing, you know, that CNN is applied only one part. Second thing that you know is this, that if I use 1 1 1 -1 -1 -1 0 0 0, this is one kind of thing. And if I put 1 1 1 -1 -1 -1 0 0 0, both the things are different. Do you understand?
Hmm.
So now where is your logic? That few minutes back you told that I'm going to use both are going to represent the same thing.
Acha, hmm.
है ना? Because why it is happening? Because you are applying something on a very small portion and you are extending that thing. So at one place you can say that things are there, but when you extend till the complete image, they are going to give you a different perspective of the image. Once again, there was one more filter that we have actually talked about, where I was telling that if you put the inner value to be high, for example 5 1 5 3 3 3 3 0 0 0, so these are the kind of enhancement they are going to do enhancement in your image. Okay, why it
Hmm.
is
Yes, sir.
happening? Because ultimately mathematically if what they represent, that one image minus another the same image, alpha time minus average of that particular image. So they actually somehow do whatever you actually create a filter, it actually represents a different kind of mathematical equation, and that is performed on the image. That's why you see a different perspective of the image. And let me give the complete kind of uh, bogus kind of thing. If I put all the places 0, it is again a filter. What it is going to give? 0. Destroyed everything.
Completely black image.
If
Yes, sir.
yeah, if I put 1 at this particular place, for example 1, what is going to happen? It is going to give you the shifting.
Hmm.
So what I wanted to right now focus bring your focus, that different kind of kernel are not same. They are going to bring a different kind of perspective in the image, and that's why they are going to represent a different kind of feature. Make sense?
Yes, sir.
Okay. Then this is the same thing that I'm talking about from the very beginning when we started the computer vision. Okay, that different kind, when you put the different kind of value into this particular filter, you are going to see the different perspective. So out of the different perspective, again I'm going to apply something to get even bigger construct out of that. So this may not totally make sense to you right now because we have not gone that much detail into the computer vision, but the idea is this: you need not to go more than this into this particular course. Okay, just try to understand that having different kind of filters is going to give you the different perspective, different kind of features from your image, and then you can concatenate it.
Hmm.
Make sense?
Yes, sir.
So let us continue
Yes,
our
sir.
discussion. What I was telling, that let's assume I have a problem. I had a question for you, so please concentrate and ask the question if you have any kind of doubt. And the question is this: I have an image of only 4 class 4. How many values are there? 16 values. And let's assume that this particular in this thing, uh, digits are written. 1 is written, 0 is written, 2 is written, anything could be written. Okay, 1 to 9, these characters are written. Okay, in this particular thing 9 is written. How to write the 9, I'm not talking about that. Let's assume that 9 is written, 7 is written, 2 anything could be written into this particular box. And now I want to develop a system that can that a network based system that can tell what is written into this particular thing. How can I build that particular thing? So so definitely I have to flatten this. So all these values, 4 values, then next 4 values, then next 4 values, then next 4 values, I have to flatten it. This part is clear, that from this particular thing I have flattened it. 16 values I am going to get. Yes or no? Just write y or n. I got this. Yes. Now I am going to put in the first layer. So let me say that I have created the first layer. Okay, if after input layer, this is my first layer. Here I'm not sure about how much many, but let's assume that I put 20 neurons. Okay, I put the 20 neurons, and each of them, then as you know that it is a classification kind of part, so everything is going to be connected to everything. So everything is going to be connected to everything. So you are going to, this one is connected to all of them. Similarly, similarly, this one is also going to be connected to all of them. So all of them are connected to all of them. This is the first layer. Then I put the second layer. Okay. Similarly, I can put whatever number of layers. For example, here I put 15, and then I keep adding the number of layer. At the end, this is the output layer. How many neurons should be here? Here there would be 10 neurons because 10 numbers are there. Na? So there, here we would be having 10 neurons. And each of them are going to represent with respect to whether it is 0 or not. What is the probability it is 1, what is the probability it is 2, 3, 4, 5, 6, 0, and 9. Okay, this is my setting. Once again, this is my setting where I am feeding what? I am feeding a 2 cross 4 cross 4 image, and my system is going to tell that what is the probability that this particular number is 1 to 9 for each of the digit, and then I can tell that whatever has the highest probability, I can say that this is what the particular digit is. So you understand this part? Say yes or no. Yes. Anybody? Yes. Okay. So next thing I am going to tell. Next thing is this, that I am going to have a different kind of architecture where I'm going to tell that this 4 cross 4 is here where this number is written into this particular thing, and I'm going to apply a CNN on that. So you know that how the CNN works. So first it is applied on here and then find out some value, then it applies over there and find out the value, then it applies here and find out the value, similarly here and find out. So different kind of places I am going to put and find out that what is the value that I'm going to get. So this you can also assume into the same way that you are going to flatten all these things. So what happens that this was the location, let me say that this was the location 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So here also 1 2 3 4 5 6 7 8 9 10 to 16, and this is the flattened level, the same layer, it is going to be over here. After that, this was put over here. Okay, maybe 16 such things. So again, if you want to develop the classification head, you have to put 16 such thing. Okay, you again put the 16 such thing, and here the nodes which are here, they are going to be connected. But you know that when you put this thing, this kernel at this particular place, it is going to be multiplied with these values only, because ultimately what is the output you are going to get? You are going to get, you apply over here and then you get a value, then you apply over here, you are going to get a value. And if you are going to be, stride is 2, so these values and these values you are going to get. So into the next layer means after doing this processing, whatever output you are going to get is going to be dependent upon what? So this particular value means 1 2 5 and 6, 1 2 5 and 6, these things are going to connected and you are going to get a value. Next value you are going to connect by this, here you are going to get this value. Next thing you are going to get here, and from here and from here, and so way these values you are going to get. So now the question comes, that this is the layer where in this layer things are connected by only two things, four things. This is also connected by four things, and above that again you can make the same kind of thing. If there is a CNN, then it would be a sparse connections over here. So what I wanted to tell, that these connections are sparse. Sparse means what? They are not connected, because you can see that this could be earlier what was happening. This was connected with all of them. It was a dense connection. Now I am telling that this connection is a sparse connection. Okay. Now the question is coming to you. Do you understand this part or not? Yes or no? Yes. Now I have a question. Which particular model has more power? This or this? Hmm? Let me call it first. Let me call it A. Let me call it B. Which has the more power? A or B? Mohit is telling A. A. Definitely A has a more power because it has more connection. Na? So it is better to have more connection. If you are removing the connection from here, is it a good idea? No, it is not a good idea. Makes sense what I wanted to tell you? That if you are removing the connection, because you can see that this has more connection, this particular item in this particular setting, this particular node has more power as compared to the original thing. Okay, here you are telling that less connection I am going to use. So would anybody would bash you that you can use this thing? Would support you that you should use this kind of network architecture? Nobody is going to support you because here you are actually reducing the thing and you are weakening your network architecture. If in your communities people are using this kind of thing and you come up with this kind of idea, you know that fully connected thing was earlier established and now CNN has came later. So whether anybody would like to support this particular thing, answer is no, this is not a good idea. So I wanted to tell you that CNNs have a sparse connectivity with respect to the neural network. So that's why from very naive perspective looks like that they are not good architecture to go ahead. Everybody agree with me? Yes or no? Yes. However, if you if you make the enough look, generally what was happening generally what was happening in this kind of setting, the number of layers that you were actually earlier applying were very less. 3 or 4 layers you actually apply because if you put more layers you are not able to train that particular system. Earlier it was happening that you cannot put many layers at this particular place, you are only having lesser number of layers. But now using this kind of arrangement, what is possible that now you can make the more number of layers. If you make more number of layers, what is going to happen? It is going to happen that okay, this particular, you just consider any for example, let's assume that these are the neurons being put into the layers. So this particular thing is going to be attached with these only, this particular one is going to be attached with these only. Okay, so if you see the output of this particular thing, once again, if you see the output of this particular thing, this particular neuron, it is only attached with these thing. But since these are attached with these previous one, so what happens that this is going to represent everything into this particular network, because now you can see that direct connections are not that it is going to be connected with everything, but whatever they can compute in some way, the some consolidation is possible. And this may represent, by using right kind of weights, that it may represent everything that is inside into the thing. And similarly for all other things also, it's going to be connected in that particular way. Just forget about the border cases because we are not that much interested. If this is very large, so it is going to cover everything whichever are inside into this particular place. So by applying the CNNs, what we have achieved? We have achieved that now we can apply many layers, and even at the top layer, this particular thing can represent the output with respect to, that is actually with respect to everything, that by considering everything which has actually gone in my input. Okay. So what I wanted to tell, that interactions are actually preserved. So it looks like that you are actually doing the sparse connectivity and this is only representing these 5 things. But if you go at the higher level, those neurons would be representing the interaction with all these things. And that's why the power comes into this kind of architecture. Make sense? Yes or no? Let me tell you one another idea that is also very important with respect to the CNNs. And this CNN is idea. The idea is actually the weight sharing. You know that what is weight sharing? Do you know what is the weight sharing? So weight sharing means when into the next layer, when you are going to apply a CNN into this particular place. So the weight that is actually that the weight that is here, the same weight is going to be here. So one side you can say that I have advantage that if I find out this particular value, I need not to find out this value because earlier what was happening that everywhere the weight were different. Okay, everywhere here if I want to see the connections, so if this is the weight and this is the weight, if you consider all these weights were different. But here in this particular setting, you into the CNN, this weight and these weights are going to be the same. All these weights are going to be same. But At the same time, I was telling that who is stopping to use only one, so you can put a different kind of filter also, and this that particular filter would be having the different weight. But when you are going to apply that particular filter on the complete thing, at that time everywhere the weight is going to be the same. So essentially this diagram I wanted to tell that if you apply the multiple filter, 1 2 3 4 2 3 different kind of filters, so different kind of colors are representing different filters. So on the same value, first filter is applied, here also I'm going to apply the filter and their weight is same. This is another thing where weights are same, here another thing the weights are same. Okay, once again I have a question. So is it a good idea? Because if I say you, just see that very basic question I'm asking. If I say you, yeah, what are you doing? You can you if you use a different value over here, different value over here, I am going to allow you to use different value everywhere. What is the problem? I am allowing you to use the different value na, so you can use the same value as well. So if I allow you that to you can use the different values, so whether I am going to give you more power or less power, if I allow you that you can use the different values as well, so I am going to give you more power. Why you are thinking that you have any kind of issue? So the system would have more power if I allow you to use different weights here and here. Just just focus on any of the filter. If I allow that my filter can use the different weight at the different places, and which was the general scenario at the time, that particular model has a more power as compared to this one, which has the more restricted arrangement, where I'm telling that the same weight you have to utilize, same weight you have to utilize here and here, same weight you have to utilize here and here. So again, what I wanted to tell that CNN are destructive and they have less power. Do you agree with me? Yes or no? Yes. CNNs are restrictive and they have less power. Then why should I use the CNN? The reason is this. The reason is this, that into the computer vision, let's assume that you have an image. And if you apply again, I would give you the same naive example of the filter. This is my very favorite filter 1 1 1 -1 -1 -1 0 0 0. It is going to give you the vertical filter. What it is going to give you? Any vertical line which is there in your image. Okay, this is the going to discover the vertical line. So if you want to discover the vertical line, you have to apply this particular filter R across this particular image. Yes or no? Yes or no? You have to have, if you want to find out the vertical line, you have to apply vertical edge. You have to apply this filter into all across the complete image. You have to apply all across the image. If you are here, you are applying this filter, and here at this particular portion you are applying some other filter, okay, with some other value. So whether you would be able to discover this feature? Yes or no? No, you what what the hell I'm talking about? If you want to discover the vertical edges, okay, vertical edges, then you have to apply this particular filter all over. If somebody tells you, Array, I give you the complete freedom to apply anything anywhere, here you apply this, here you apply this one, and at this particular place you apply different filter, 1 1 1 -1 -1 -1 2 3 5, you can apply this also. I'm going to allow you to do that. So what does it mean? I'm allow you to do the suicide. It's not a good thing, because here you are finding out different feature, here you are finding out different features. So overall image, you are actually, you are not doing the image processing, you are destroying your feature itself. So however it looks like that this particular thing that I'm restricting you to use the same value all over the image, because this is all over image na? This is all the flattening thing. I'm going to say you that use the same value all over the image, but actually it is sensible thing to do into the computer vision. If you don't do this, you are actually not doing the image processing to the right way. Makes sense? This is also a very important point, that this weight sharing is essential. Looks like that it is bringing the less power, but actually it is bringing the right thing with the perspective of the computer vision problem. Okay, so this is again a very important thing. Next thing that I wanted to tell you is that's something called the pooling. Okay, sometimes what happens that you know that in your case, if an image is given to you and you want to tell whether there is a cat or dog, you know that yeah, cat and dog 0 and 1 is sufficient to represent whether there is a cat or dog, but you are taking 500 cross 500, 500 cross 500 image, so many pixels you are going to feed to the system, and system is ultimately going to give you only 0 and 1. Okay, so it would be nice that if you can come up with a feature somehow we can consolidate. Okay, we somehow we can consolidate those feature also. This is also requirement. Okay, so that at the end we actually reduce to less number of value, and we actually finally target to this particular kind of consolidation where you want to essentially tell that whether the item is there or not. So this kind of consolidation can be done using something called the pooling, and this is a very simple idea, and the idea is this, that if you apply a filter, so the idea is this, something is there. So let's assume that you have something. Okay, some image was there, you applied some filter, multiple things you have done, and you have come up after that, you come up you with some value. Pooling says that if you want to do a pooling on this, so you have to tell that what is the size of pooling. Let's assume the filter size is 2 by 2, so I am going to consider this particular area 2 by 2 area, and here you can apply anything. For example, find out maximum, minimum, or average. Most of the time maximum is we use max pooling because maximum is a prominent value. Now you want to find out who is a prominent in your class, so prominent, who is the maximum student, best student in your class. Most of the time we don't like the minimum one, and the average is again is a kind of representation of maximum only. So most of the cases we actually use the maximum, max pooling only. So who are the most important thing? If you want to use, you have to use the maximum one. So I'm going to apply a 2 cross 2 filter, and I'm telling that I'm going to do the pooling. So if it is a maximum pooling, I say I give it another name called max pooling. So by yourself you can tell that in this particular area, what is the maximum value? 1458. The maximum value is 8. So next value I can put it here in the max pooling. So what is the next value? Next value is going to be 4. So I put 4 over here. So if can I use this thing? I'm telling you very important thing. Look, in the examination, most of the time people get confused. If I say that apply a pooling, so you find out the value from here. Okay, if the pooling is 2 cross 2, and I'm not specifying that what is the stride, you have to go to this particular place. Okay, if you start taking this particular thing, it is wrong. If I say that take the thing from here, if I say that a stride is equal to 1, then you take this particular one. Otherwise, you must go to this thing. For example, when I apply the filter, when I apply a filter, for example, 2 cross 2 filter, if I don't tell you that what is the stride, then stride is equal to 1. But in case of the pooling, if I don't specify, use this particular value for the, if I don't specify the stride would be 2, equal to the filter size in the case of pooling. Okay, so what is the next value I'm going to find out from here? It is going to be 4. Next value I'm going to find out from here, this is going to be the 7. Next value I'm going to find out from here, so the maximum value is 5. So this is what I'm going to get the output. As I told you that if the stride is equal to 1, if the stride is equal to 1, then from here, after this, you go this particular place and you find out what is the maximum. And similarly, you go here and find out the value. And similarly, you can come up with this kind of feature map. You know that pooling can be maximum, minimum, and average. And by this, you can find out all these things. Any questions on that? Yes? Yes? Or no? No questions? Great. So once again, this is what the question is, that how do you train the CNN? Answer is back propagation. You deploy the back propagation, it is going to give you the right parameter. Uh, Parsaw is, sir, why not take average? I am confused. Okay. So why you are confused? So this is a question. Now, what is the confusion? So why not take? I am not telling that you don't take this. Okay. This depends upon, there are some situations where this average works well, and most of the time it is going to be the hyperparameter. So people try maximum, minimum, everything, and they test it. and average is also going to be working in some cases. So maybe at a later point of time we would see some architecture where average is going to be deployed over here. But if you want to find out something that stand out up from this particular image, you what you want to report, you want to report that what is the important thing, what is the which particular value is going to give you the most biggest output. So you must take the maximum value. This is only the idea. Okay, what I wanted to tell that in most of the scenario, minimum is not that thing that actually we are focusing on, because most of the values in some of the computations could be zero also. So if you taking zero, if you take the minimum, if you start taking the zero minimum, so at the end what is going to happen, you are going to destroy the complete thing. Okay, is pooling is a kind of type of filter? This again a very important question, whether pooling is a filter. So what do you mean by filter? Filter is something that actually has some value that you specify. Okay, Josh, it has a value. So whether max has anything to tell, any value it has to tell. Okay, it does not have anything, so there is no parameter. You must understand that there is no parameter over here. Pooling does not have any parameter, so we cannot call it a filter. Okay, however, out of these values it is going to find out the maximum, minimum, something. Implementation issues we don't want to discuss at this particular point, that how to implement that. But right now try to understand that there is no parameter over here. In the general filter there is a parameter. Parth, are you getting the answer? Yes. All right, so let us go forward and try to see in CNN architecture that is very popularly known, and we have actually discussed talked about this earlier also. So this is a paper that came out around 1998. The importance of this particular paper is this, that this paper in 1998 had proposed CNN kind of architecture, CNN kind of architecture. And however, after that, people were telling that neural network is dead. And the same, the AlexNet was actually inspired by this architecture. And in around 2011, the AlexNet was actually applied on the ImageNet challenge, and actually has shown the real possibilities of these kind of architectures. So the architecture which was actually existing into the literature from 1998, people were actually not using that. Why? Because at that time data was very less available, the computation power was very less available. These kind of architecture has lot of computation to be done, and this was not possible to be tamed into the general kind of setting. So at that time the processing was not available, so people actually stopped using these kind of architecture. But let me tell you that this is one of the fundamental architecture that was utilized to develop the neural network architectures. Make sense? Okay, so let me talk about this. This is a architect, this is a paper called, can you read this? And this is uh, Jan Likun and Yashio Bengio paper, and you know that he is one of the top research into this particular area. The paper is gradient based learning applied to the document recognition, and as I mentioned that it came out in 1998. The idea is this. The idea is this, that you are going to use an image that is 32 cross 32, and from this thing, and then you apply a convolution on that, and the convolution you apply with this kind of interesting thing, and the filter is going to be of the size 5 cross 5. 5 cross 5 filter means what? That you are going to use 5 cross 5 filters to, this is the size of 5 cross 5. So how many parameters it would have? 25 parameters. Okay, so it is telling that 6 number of filters you are going to apply. How many kernels? K is equal to 6 means what? 6 number of filters are there. So how many total number of parameters are needed at this particular place? So you say that 25 is there inside one. So 6 such things are there. So 150 number of parameters are there. How many parameters are there? 150. Any questions on that? What is the output? So since input was 32 cross 32, so we know that the formula is 32 minus f divided by stride, and stride was actually 1 and padding was 0. So plus 0 plus 1. So this is the answer where s is equal to 1. So what is the size? Can you tell me? F is equal to what? F is equal to 5. So what is the answer? So 32, I think 28 cross 28. The answer is 28 cross 28. So you get the output of the size 28 cross 28. Any problem on that? Just write yes or no. Is it clear? Then the next is the pooling layer. Next layer is the pooling layer, and max pooling, min pooling, all these things we have seen. So for everything you are going to get one. If you apply the pooling, so pooling the filter size is 2. So every 4 item you are going to get one item out of that. So this 24 item, 28 item which were there, actually you get 14 item out of that. So you, the next output is going to be 14 cross 14. How many filters, how many kernels? So six kernels need to be there, because you have to apply for every layer you are going to get one layer out of as an output. So again, from there 6 things, you again get the 6th thing as an output. How many parameter? Nil. There is no parameter, because as I discussed few minutes back, that pooling does not have any kind of parameter. That you, parameter means things which actually you change. You don't change anything. Okay. Now the next layer. Next layer says that I'm going to apply. This is a very interesting thing. Okay, focus on this. It is going to say that k is equal to 16. So you are going to get how many things? 16 things. So here you can see that 16 things you are going to get. With respect to every filter, you are going to get what? What is the size of filter? 5 cross 5 again. So how many parameter would be there into the filter? Can anybody write? It is 5 cross 5, because filter has 5 cross 5. But you cannot this time. Earlier what was happening, when this filter was applied, here only one layer was there. But here when you are going to apply the filter on this, there are 6 such layer. So 5 cross 5, 5 cross 5, 5 cross 5, everywhere you need to have the 5 cross 5 value. Then only you can apply the filter. So how many values there are? 5 cross 5 cross 6, these many values into one filter. How many filters are there? 16. So these many number of parameters you need. So can you tell me what is this value? 5 cross 5 into 6 into 16. So let's like, it looks like that it is 2400. This many number of parameters are here. So what is the output? What is the output size? Output size again 14 cross 14. So it is 14 minus 5 uh, plus 0, 2p divided by stride is 1 plus 1. It comes out to be what? It comes out to be what? 15 minus 10. It is 10. It comes out to be 10. So therefore the output is of 10 cross 10. Yes? Okay. After that, again, there is a pooling layer, and this is the again the max pooling layer that actually find out the maximum. So number of parameters is going to be the nil. There is no parameter over here. Filter size is 2 cross 2, so half things would be half. So you are going to get the half things. So how many such planes? 16 such planes. For every plane, how many values is there? 5 cross 5, 25 values are there. So how many total values I have? Can you find out this value? 25 into 16, how much it is? 25 into 16, how much it is? 25 into 16, it is 400. Am I right? Just tell me. 25 into 16, it is 400. 400. So this, what I wanted to tell, that this thing is going to give you 400 value. 400. Once again, let me. So I was telling you na, that with this 400 value need to be flattened. So you can assume that here, there you are going to get how many values? 400 values. Next layer is a fully connected layer. Next is a fully connected, fully connected, fully connected. So this is the output layer. So into output layer, how many output would be there? There would be 10 output, because 10 classes are there, because it's a number. The database that they use was a digit database, so 10 numbers would be there. So output layer would have the 10 thing, but before that 84 and 120 number of neurons were there. So each neuron is going to be, if you consider any neuron into this particular, any neuron in this particular layer, it is going to be connected to each of them. So how many parameters you need to have? 400 plus one number of connections you need to have. So how many such things are there? 120. So these many number of parameter need to be here. So four. So these many number of parameters are needed at this particular layer. Do you understand this? 48120. Just find out the multiplication. If you consider the next layer, there this would be again need to be connected to everything. So how many things are there? There are 120 plus 1 values. Then there it is multiplied by 84. So these many number of parameter into the next layer, to the final layer. And to the final layer, how many parameters are there? If you pick any one, they need to be connected with the 84. So it is 84 plus 1 multiplied by 10. These many number of 850 number of parameters. So huge number of parameters are there into the system. And you see that by this, you see that the huge number of parameters are there. And this system was being utilized to find out the classification of digit. Very influential and very grounded paper of our ML community, deep learning community. So I would stop at this particular point. In the next slides, and in the next class, we would see that after seeing this particular paper, how the LXNet had actually utilized the 8-layer protocol. And this is the actually I had onto my slide. If you find the time, try to see this. And however detailed we would see into the next class. Thank you very much. Thank you for joining this session.